Hi viewers, welcome to the new video. In this video, we are going to see a new category of signals, energy and power, and deterministic and random. So first we'll see what is energy signal and what is a power signal. So among the given signals, in order to identify whether the given signal is energy or power, then we have to apply the formula of energy and power to the signal. Then based on certain conditions, we can decide whether the given signal is energy signal or power signal. So first let us see the formula for energy and power of a given signal. In order to calculate the energy of a given signal, the notation for energy is E. E is equal to integration minus infinity to infinity and the given signal square. This is the formula for calculating the energy of a given signal, provided if this signal is of the category continuous in time. Otherwise, E is equal to summation n equal to minus infinity to infinity x square of n. This is the formula for DT signals, discrete in time signals. And similarly, power notation is capital P. P is equal to limit capital T tends to infinity 1 by T integration over one time period. This is called integration over one time period. It could be minus T by T to T by 2 or only simply one time period like 0 to T, T to 2T like that. X square of T dt. This is the formula for calculating the power of a given signal for the category again CT. This is for CT signals. So I won't write it here because there is no space. So the first formula is for CT and the second formula is limit n tends to infinity 1 by 2n plus 1 summation n is equal to minus n to n x square of n. This is the formula for DT signals. So these are the four formulas which are available for us to calculate the energy of a given signal or power of a given signal. Now coming back to the question, how to identify whether the given signal is energy or power. So first calculate this E, energy value. If E is becoming finite, then directly can conclude that the given signal is energy itself. I repeat, if E becomes finite, by using this formula, calculate E, and if E becomes finite, you can conclude that the given signal is energy. For such a signal, power will automatically become 0. And in order to decide whether the given signal is power, what we have to do is, again we have to calculate energy. If E becomes infinite, then we have to calculate P, and if P becomes finite, then the signal is said to be power signal. So I repeat again, the condition for power signal is E should be infinite first. If E is infinite, then calculate P. If P is finite, then only the signal is power signal. Otherwise, the given signal is neither power nor energy. But in reality, such kind of signals are not there. Either it will become energy or it will become power. Right? So, just calculate the energy first. If it is finite, conclude it is energy. If it is infinite, then go for P calculation. If it is finite, then say it is a power signal. But one hint here. If you can identify whether the given signal is periodic or aperiodic, you can directly say it is energy or power by looking at the signal. All the periodic signals, almost all the periodic signals, most of them are going to become power signals only. And all the signals which are non-periodic, which are aperiodic, or most of the signals which are aperiodic will fall under the category of energy. So by looking at the question, if you can identify whether it's periodic or aperiodic, you can say it's energy or power also. So you can use this relationship between these energy and power with aperiodic and periodic signals. So that's about energy and power signals. So I repeat here again, if E becomes finite, signal is energy. If E becomes infinite, then calculate P. If P is finite, then it is power signal. If E is finite, it's energy. If E is infinite, it may be power. Calculate P. If P is finite, then you can conclude it is power signal. Now coming to the one more category, deterministic and random signal. A signal which can be expressed in the form of mathematical, like x of n is equal to cos square n, or x of t is equal to cos square t, x of t is equal to cos 100 pi t plus sin 50t. So all such kind of signals which can be expressed in the form of mathematical form are called as deterministic signals. A signal which cannot be expressed in the form of mathematical form is called as random signals. They are called as random noise. Example is noise generated in electronic components or in the cables will fall under the category of random signals. A signal which cannot be expressed in the form of mathematical form is a random signal. There are no numericals which we are going to solve on this category, because whatever the expression given to you itself is a deterministic signal. There is no question of finding again what is deterministic. And non-deterministic signals, as they cannot be put in the mathematical form, it is highly impossible to give a question to decide whether this signal is random or not. So it will be funny if I ask you, by giving a mathematical expression and ask you whether it's a deterministic or random, means you will directly say it's deterministic only. There is no question of random. So there are no numericals in this category, but there are numericals in this category.